One of the things, one of the reasons why we focused on industry specifically is that when you look at the numbers from employment status or just financial status, you realize how much of a big impact it has on the global economy. For example, in America itself, 12% of employees are working for the manufacturing side. One of the other interesting factors, as much there's to promote manufactured jobs to come into America, because we're blaming it coming overseas, the actual numbers contradict. The total output of sales that contribute to the GDP based on manufacturing is almost the same what it was when we had the highest rate of people working for manufacturing. And the main reason being is because of the technology that's reducing the cost and increasing the output of it. So this is one of the main reasons why, to begin, we focused on robotics. So when people think about robotics, they think a lot of times about some humanoid machine, but reality, these are machines that are doing very limited features, like based on axis. Whether they go and they drill, they mill like this, or they go around, or they paint, at this angle. These are the real robotics, or the machines that actually help the industry throughout the world manufacture, from your favorite shampoo down to spraying the car itself. So some of the key things we found is that a lot of the security issues are not really related to the robotics, but the entire environment. One of the big problems being is that a lot of these devices were installed, they're put in years ago, and they're leveraging operating system, for example, Windows XP or Server 2003, which are completely unsupported. And it's based on the manufacturer's criteria, like you cannot touch the system. If you do, it'll break end user license agreement. So even before the robotic, the issue is the programs that control the robotics are completely wide open to vulnerabilities. So in terms of what can impact from a cyber standpoint on manufacturers, that, if you could potentially impact the robots that produce. So when we think about robotics, we're thinking about manufacturing lines, so we think about upstream and downstream. So if there's something that would occur during the manufacturing process, it doesn't just impact what point or what it's doing at that point. You got to think about it. It's a chain reaction. Now, what happens prior? You could shut down the manufacturing line. That goes all the way up to supply, raw material coming in, raw material being processed, people going out in the actual manufacturing facility, putting, let's say if it's aluminum blocks that's going to get molded, this could be prevented. So you have a whole issue of human resources, from human resources down to what do you do with actual supplies that are coming down the supply chain. The other thing is downstream. So now if you have an issue with shutting down your manufacturing facility, what about the actual output that goes out? A lot of this data is actually utilized for, especially publicly traded company, for their stock prices or commodity prices. If all of a sudden, if you have a big manufacturer that got hit with, that leverages aluminum, and now saying it's shut down, the demand for aluminum just went down because no one's using it. So it's interesting. It's a chain reaction of events that take place that affect both upstream and downstream. So what manufacturers can do to help secure the infrastructure, it's pretty basic. We're not telling these companies to go out and invest $500,000, $1 million. A lot of it is basic stuff. One of the key things I always look at is, if you look at a lot of these robotic devices, one of the things they have is, for machinery, it's called CNC controllers. So a robot by itself is pretty dumb. You need to send it certain codes where it tells it, hey, I want you to go and drill 2 millimeters and go out, or I want you to go on this angle drill. That is all done by a controller. A lot of these actual controllers just have like a one-to-one relationship where they only talk to the workstation, we call the HMI, to the actual controller, or the controller is isolated, connected to the robots. If they are networked and there's no reason for them to be talking to anybody else, isolate them. That is by far the greatest way to secure, from a logical standpoint, to protect them. That way, if someone's already in the network, they are very limited in terms of attacking the actual robotic devices, and they'll be limited to whatever is out there. So isolating the actual robotic equipment and devices that are in the manufacturing facility. So in the in the industrial manufacturing sector, the manufacturing, in terms of how aware they are, I think out of all the critical infrastructure, they're probably the ones that are probably the least aware. Reason being, A, it's not regulated. Unlike energy, where it's heavily regulated, we've seen high profile attacks that happen, and with power, you get governments involved. Like in the U.S., we have Department of Energy. You have the different laboratories for DHS actually gets involved, or even Department of Justice. So the scrutiny, the eyes are not there compared to the energy. At the same time, it's just scary that the sheer amount of input it gives to the economics of the world, whether it be the U.S., China, Russia, that it can do significant damage to the economy or to the economic security of a nation. Lately, there's been talks, but again, there's no regulation, because unlike energy, where it's specifically focused, I'm producing power, transmitting power, I could be producing, or Company X could be producing shampoo and conditioner, Company Y could be using robotics to color cars. So as a whole, everybody's, they're using robotics for different purpose, so it's hard to just bundle them. I mean, governments are going out there encouraging them to say, hey, you could do better practice, but there's no big trade association or that actually promote, that encourage cybersecurity in there. I mean, there are, but again, because it's a big but very loose-knit community. What separates IT and OT for these environments? So one thing is, for people who are not aware, in the traditional landscape of net computers, it's only an IT network. The moment you get into industry, when they leverage HMIs, PLCs, RTUs, robotics, we refer to that as the OT, the operational technology environment. Now, in most cases, they're typically two separate networks, because security, or there's no reason. I mean, like, the people that manage the OT environment, they're not IT people, they're actually engineers. So if you're in a power company, it'll be, for example, like a substation protection engineer. Or in a robotics, you may have a machine specialist, an actual machinist that's responsible for configuring or setting up the codes that deals with the robotics. So it's a culture gap. So in the traditional IT world, you can easily talk, or you have organizational leadership like a CISO or CIO. In the other part of the world, that doesn't really exist. So it's a challenge to convince engineers to say, hey, fix something that's technically not broken. For them, whatever they invested into, that's like a 10-year, 20-year investment. And for them, looking at, like, I bought this whole package to make product X, including this computer and this robotic. We are not going to mess it up to impact production line. So I mean, it's a tough challenge. I mean, you're dealing with actual engineers on the ground, and it's one of the things is like to actually make that awareness of cybersecurity so they can start thinking better. So you may not, you're limited what you can maybe do to that machine, but you can definitely put the like the fences, the walls, the physical security around to protect it even more than what it is right now. As I like WannaCry. WannaCry was a great example. When we had Nissan and Renault, for example, shutting down their production facility, that actually impacted production line, impacted industries where they utilize robotics. The heavy investment into automation, the high, especially in places like America, where the increase of the minimum wage to 15 has really forced companies to think about how they reduce costs, and that one of the ways you do it is leveraging automation through robotics. In California, for example, there are places in fast food industry where you have robots that are flipping the burgers, because $15 an hour compared to one-time investment, and you can make that robot work from 9 in the morning down to midnight, and there's no issue. So technology, the technology is going to get much more better, more efficient, and cheaper. So that means much more abundant of robotic devices. At the same time, that means a larger footprint. So you have the big, like the big manufacturers that probably control 90% of the market. The other 10 is that growing emerging market, which whether it be IoTs or these small companies, that's going to continue to grow and specialize. So as this grows, and we actually see this more, whether it be a robot that actually stocks the shelves at a grocery market, or a security guard that's actually a robot, this is when people start interacting with this more, the awareness to actually target these is going to increase as well. So definitely the increase of attacks, probing, automated robotic devices will probably increase in the next couple of years as the industry pushes more automated devices out there.